this first example, we have ourselves a geometric series. We're trying to find out the interval of convergence. All right, well, we know that that will converge when the absolute value of the common ratio happens to be less than 1. So we just got to identify what the common ratio is. What are we multiplying by each term? All right, now if you see right away that the common ratio right here is going to be x over 3, that's great. All right, go ahead right away and work it. If you're not sure, keep in mind that you can always write out a first couple terms and help you to identify what the common ratio happens to be. All right, if n is 0, then we have negative 2 times 1 over 1. So our first term would be negative 2. And then our next term, we have now n is 1, so we're going to have negative 2x over 3. All right, and we can see, what do we multiply by? We multiplied by x over 3. But if you're not quite sure, let's do another term. All right, so now we're going to have negative 2, and then n is now 2, so it's x squared over 3 squared. All right, and we can see that once again we multiplied by x over 3. So our common ratio is x over 3. The absolute value of that ratio must be less than 1. All right, so we know that since the absolute value of this term is less than 1, that means that this term itself must be between negative 1 and 1. All right, and we're just looking for x to be isolated in this middle of our compound inequality, so we'll multiply every term by 3, and we see that we have an interval of convergence where x can be any number between negative 3 and 3. So when x is any one of those values, then we know that our series is going to converge. If x happens to be 5 or negative 12, then the series that we have here is not going to actually converge on our function, and therefore it doesn't do us any good.